this video we are going to talk about the kind of solutions that we will have. In summary, we are going to have two solutions: implicit solution and explicit solution. On the previous video we have the classification of the differential equation, but now here is the classification of the type of solutions. Okay, this is very simple, engineers. The solution is the same, but it's just a technical aspect. The implicit solution is, here is the example of this differential equation, and this is the solution. Here, what makes it an implicit solution is that the y cannot be clear. Well, in this case, clear, despejado in Spanish. So y is not clear, no está despejada la y. On this example, which is the explicit solution, this is the differential equation and this is the solution. As you can see here, the y is clear, la y está despejada. So this makes it explicit solution. When we are going to solve differential equations, we may get this solution or we may get this solution. Ideally, what we are going to try to get is the explicit solution, all right? But sometimes it's not going to be possible to get the explicit solution, so you have to leave it as implicit solution. Okay, when can you make or get the explicit solution? Well, that depends if the algebra allows to be capable to clear the y, and not always is possible. Okay, now why we have these two? Because to check if the solution is different according to the implicit or explicit solution. And here I'm going to do the example. How to check if this is the solution? Remember from the first video, a solution is something that meets or comply with the differential equation. Okay, now on this one we are going to, how are we going to replace this in the differential equation? So what we have to do is something that we do in the first course of calculus, which is implicit derivative. Implicit derivative. That is why the name of implicit solution. On implicit derivative, what you have to do is apply derivatives in both sides of the solution. And this is the procedure to check if it is solution. So let's apply derivative in both sides, derivative respect to x in both sides on y plus y squared equal to derivative respect to x of x squared plus the constant. Okay, be careful here. Derivative of y respect to x plus 2y derivative of y respect to x. That's it. Here we apply the chain rule, regla de la cadena, to get this derivative. And this is on the left side. On the right side, what you have is derivative of x squared is just 2x, derivative of the constant is 0. From here, let's clear the derivative of y respect to x, factorize it. Derivative of y respect to x is equal to, times 1 plus 2y equal to 2x. So the derivative of y respect to x is going to be equal to 2x over 1 plus 2y. And as you can see here, this is the original differential equation. So on the implicit solution, when you try to know if that is actually the solution, you have to apply implicit derivative in order to get the differential equation. So this is the procedure to check implicit solution. So I'm going to make it here. All this part is just procedure to check implicit solutions. Now, what about the explicit solutions? On the explicit solutions, what you have to do is something different. Here, because the y is clear, you don't apply implicit derivative, you just take the derivative. But here what you have to do is to replace in a differential equation. Alright, so let's do the procedure. Derivative of y respect to x, I'm going to write smaller because it's going to take some space. So the derivative of this is going to be, because we have a division, this is u over v, so it's going to be 1 plus exponential of 2x squared, and the numerator is going to be 1 plus exponential of 2x times derivative of this 4 exponential of 2x, and then minus 2 exponential of 2x, derivative of what is here, derivative of 1 is 0, but derivative of this is going to be 2 exponential of 2x. So here we take the derivative of y with respect to x is going to be equal to, here let's do some reduction. So this times this is going to be 4 exponential of 2x plus 4 exponential of 4x. Be careful here because you multiply this times this, and then minus 4 exponential of 4x. That divided by 1 plus exponential of 2x squared. Now I can see here that this and this cancel, so the derivative of y with respect to x is just 4 exponential of 2x divided by 1 plus exponential of 2x and then square. Okay, now that was the left side of the differential equation. Now let's do the other side. In the other side, what we have to do is 2y minus y squared. So 2y minus y squared is going to be, here is the solution because it is an explicit solution. You have to do this 2 times the y, this one, 2 exponential of 2x divided by 1 plus exponential of 2x, and that's it. And then minus the same solution squared. So it's going to be 2 exponential of 2x divided by 1 plus exponential of 2x and then square. Okay, let's see what happens here. So this is equal to this times this is going to be 4 exponential of 2x divided by 1 plus exponential of 2x minus, here the power is going to be 4 exponential of 4x, be careful here, divided by 1 plus exponential of 2x and then square. Okay, now let's do common denominator here. When we do common denominator, the common denominator is going to be 1 plus exponential of 2x squared. Now you can see here this is the same number. It's just that here is power 1 and here is power 2. So the common denominator is this number. So this divided by this times this is going to be 4 exponential of 2x times this number, 1 plus exponential of 2x, and then minus this divided by this is equal to 1 minus 4 exponential of 4x. Okay, let's see what happens here. 4 exponential of 2x, this times 1, and then this times the exponential, plus 4 exponential of 4x, be careful with the powers, and then minus 4 exponential of 4x, divided by 1 plus exponential of 2x squared. So what is the result of this? This and this cancel, so what you have is 4 exponential of 2x divided by 1 plus exponential of 2x squared. Now, is this the same as the derivative of y with respect to x? Well, the answer is yes, because they are the same. Is that expected to happen? Yes, because it's supposed the derivative of y with respect to x is supposed to be equal to 2y minus y squared. So here the derivative of y with respect to x is this number, and the 2y minus y squared is equal to this, and they happen to be the same, so the differential equation is met, or it complies with the differential equation. Because you have these two equalities, then it is solution. And this is the procedure to check explicit solutions. Alright? Okay, now this is just the type of solutions and how to check the solutions. When you are going to solve differential equations, you may get explicit solution, implicit solution, or you get explicit solution. You will try, the best is to get the explicit solution, but it's not always possible. Alright? Okay, so far we haven't seen how to solve differential equation. All I have seen, or we have seen here, is what is a differential equation, what kind of differential equation you will face, and what kind of implicit solutions you are going to get. Alright? Next video we are going to deal with the initial condition problem. And then after that we are going to start with the first method of solve differential equations.